Hi, welcome to our next set of notes. We're going to be talking about standard form and talking about finding a solution to an equation. But before we get started, I just want to give you a bit of advice, a word of advice. So just when in doubt, just take the next small step. And another one, life is too short to waste time hating anyone. So getting back to our notes, what I have here at the top is slope-intercept form, which we've already talked about in class, and now introducing standard form. So every function that we're going to work with this school year has something called standard form. And this is the one for linear functions. So we can connect both y equals mx plus b and ax plus by equals c. So when I say that we can connect them, it's talking about the two equations to be equivalent. And so what does it mean to be equivalent? It means that they have to have the same solution, or they have to be the same solution. Okay. You know what? I think I'm going to switch to a pen. I just feel like that pencil is kind of hard to show up. The next one is it easy to graph a linear equation in the form of y equals mx plus b on a calculator? Yes, it is. Okay, and we'll be doing quick graphing with that. Can you use a calculator to graph an equation in the form ax plus by equals c? No. We are going to have to convert to y equals mx plus b. Can you change an equation from ax plus by equals c to y equals mx plus b? And yes, okay? And we have practiced this a lot with our literal equations, okay? Where we are rearranging equations. So that is where we are going to be rearranging equations. All right, now moving down to the bottom and learning a little bit more about standard form. So standard form, again, is ax plus by equals c, where I'm going to jump down here. Ax and by are the variable terms. A and b are coefficients. Okay, c is the constant or a plain number. Okay, now these are the rules with standard form. Ax cannot be a negative number, so that first term cannot be negative. That can be negative, that can be negative. Ax and by cannot be fractions, okay? C is allowed to be a fraction, but not your variable terms, okay? So these are the two key important aspects of standard form to make sure that you are doing. So what we're going to do here at the bottom is we are going to be practicing converting slope-intercept form into standard form. Okay, we've already practiced the previous notes going from standard to slope. This time we're going in the this other direction. Okay, so the very first one that we have is we have fractions, and I notice that my ax is negative 2/3, and so this one cannot be a fraction, so we're going to practice eliminating fractions. So there's that, what we learned earlier in the school year. To eliminate fractions, we multiply by the least common denominator. The least common denominator here is 12. Okay, sometimes all you have to do is 4 times 3. And every term is going to get multiplied by 12. And so when I do that, I get 12y is equal to 3 minus 8x. So again, I took y times 12, 1/4 times 12, negative 2/3 times 12 to come up with that. Now the next thing that we're going to do is we have to put it into this standard form of ax plus by equals c. So all I have to do here is add 8x to both sides. When I do that and I rewrite it, I have 8x plus 12y is equal to 3. Okay, and so here we go. It is in standard form where my ax variable term comes first, then my by, and then my c. Okay, let's go ahead and try the next one. So for the next one, I have a fraction, but notice that fraction is my constant. So it does not matter if that one is a fraction. We can leave it as is. I have my ax to one side, okay? I just have to move my y to the other side. So all I'm going to do is subtract y from both sides. When I do that, I get 2x minus y is equal to 1/2. Again, just to double check, I have this in standard form. AX plus BY equals C. Okay, so I can box that in. I forgot to box in my first one, so I'm going to just backtrack real quick. C, I'm going to save this one for class. Okay, D, we'll go ahead. D is a great one that is in our slope-intercept form. So from slope-intercept form into standard form, I'm going to move my x variable term to the other side. So to move it to the other side, I add 3x to both sides. When I do that, we get 3x plus y is equal to 5. Again, this one is in standard form where my AX term comes first, then my BY, and then my C term. Okay, so it's nice when there's only one step that we have to do for some of these. I'm going to save E and F for the next time I see you in class as well. Okay, so let's go ahead and flip these over to the back. When I flip it over to the back, over here we are talking about something called is an ordered pair a solution to the equation? Okay, so I'm going to read through this. Please just follow along. Recall that a solution is a value for the variable that satisfies the equation or makes the equation a true statement. We know this from the tables that we saw. Okay, so I'm going to just write in here from our tables. Okay. To figure out if an ordered pair is a solution to an equation, you could perform a test. Identify the x and y values in the ordered pair and plug it into the equation. When you simplify, if the solution is equivalent, then that ordered pair is indeed a solution to the equation. How many such pairs are there? We're going to choose any value for x or for y. You can always find the other ordered pair or corresponding value in the equation of this form. We say that there are an infinite number of pairs that will satisfy the equation. Okay, so an infinite number of pairs. So this means, again, what we are doing is if we choose a value for x or one for y, we are creating that table. So that's what it comes back to. So if you think back a few notes ago when we created that table, this is just another way of looking at it. So this time I have different ordered pairs, and we're going to see, are these ordered pairs going to be used? If I wanted to graph this line, would they be used? And the easiest way to figure that one out is to substitute each of these values in for the equation. So remember that an ordered pair is an x and a y. And so I'm going to substitute 2 in for x and 1 in for my y, or in this case, the f of x. Okay, so what this is going to look like is 1 is equal to negative 2/3 times x, which is 2, plus 5. And then I simplify. Drop down my 1. Negative 2/3 times 2 is negative 1 1/3 plus 5. I already know off the bat that these are not going to be equivalent, so I'm just going to go ahead and say not equal to and move on to the next one. Now, for my next one, I'm going to put 7 in for y and negative 3 in for x. Okay, careful you don't write too big on these. I didn't leave you a lot of room. So I'm going to drop down my 7. Negative 2/3 times negative 3 is a positive 2. Okay, so negative times negative is a positive. I drop down my plus 5. And you know what? 2 plus 5 is 7. So 7 is equal. This one is an ordered pair. So if I graphed this line, this ordered pair would be there. Or again, if I created the table, this ordered pair could be in the table. Let's go ahead and try this for another one. So I'm going to put negative 1 in for y, 9 in for x, and then simplify. So I have negative 1 is equal to, oh, this is negative 2/3, sorry. Negative 6 plus 5. Negative 6 plus 5 is negative 1. So negative 1 is equal. And so this one is works. Okay, and then the last one, same idea. I'm going to put negative 5 in for y, recap of the rest of the equation, put 4 in for x, and then simplify. So negative 4 times 3, that gives me negative 8/3, which is negative 2 2/3. plus 5. Well, I know that when I add these two together, I will not get negative 5. So this one does not work. So that means 4, negative 5 is not a solution for my graph. If I created a table of values or graphed this equation, this ordered pair would not be on there. Okay, let's try this one more time for B. So for B, this time I give you the equation in standard form. Notice in A, I gave it to you in slope-intercept form. So here we have standard form. Again, my ordered pairs are x, y, and I'm going to substitute the 3 in for x, 7 in for y, and I'll do the same for the rest of the ordered pairs. So that will be like 5 times 3 minus 2 times 7 equal to 1. And then I just simplify. 5 times 3 is 15, 2 times 7 is 14, and so 15 minus 14 is 1, so 1 equals 1. This first one is an ordered pair, or is a solution to the equation. But yes, it is an ordered pair as well. And then we'll put negative 1 in for x. This is why I don't like using a pen. I meant to do minus 2 times negative 3 is equal to 1. I get negative 5 plus 6 equal to 1. And again, I have 1 equals 1. So my next ordered pair is a solution to the equation. Okay, let's try this again. I'm going to put 2 in for x, negative 5 in for y, and simplify. So I have 10 plus 10 equal to 1. Well, 10 plus 1, 10 does not equal 1, so that one does not work. And then for the last ordered pair, so put 1 in for x, 2 in for y, and then simplify. So I have 5 minus 4 equals 1, and 5 minus 4 is 1 equals 1. So this last one is also a solution. So that's it with this part. We'll save C for next time I see you in class. This very last thing that we're going to do is just working a little bit more with increasing and decreasing. And so this time I give you the graph and then I give you the intervals. So what I want you to do is pay attention to the way the intervals are written, because I know this is something that some of you struggled with in class. So this graph shows y as a function of x. For each interval in the table, indicate whether the function is increasing, decreasing, or neither. So I have, notice how my intervals start at the very left and that they will go to the very right. So it starts from negative 7 and then it goes to negative 3. So as I go left to right, that's the way it moves. Okay, so remember we start right here and then we will always go left to right. That's how we're noticing whether it's increasing, decreasing, or not at all. From here to here, I should notice that this is an increase. Then it goes negative 3 to negative 1. So negative 3, again, along the x coordinates to negative 1, this is another increase. From negative 1 to positive 1, okay, again, I'm just reading the interval. This one is a decrease. And so 1 to 3, that one is an increase. And then we'll save the last two for class, okay, just to kind of, if you guys have questions, I can answer any. All right, hey, that's it for these notes. Thanks very much, guys. May the force be with you.